Welcome to the video lecture. I am Mr. Shaik Imam Saheb, working as Associate Professor in the CSE department. The topic what I am going to deliver today is Oracle Database Server Architecture. Let us see the basic server architecture of the Oracle and how it is useful and what is the importance of understanding the Oracle Database Server Architecture. Database is a collection of data and information. This information should be effectively shared among all the users who are accessing the data concurrently. Also, there should be security so that data is shared properly among the users. So the authenticity and authorization, which is known as privileges, has to be effectively given and the data should be shared. So with respect to this, let us understand a very important database, that is Oracle, and its architecture, how the data is shared among so many different users who are accessing the database. So the main objective of this video lecture is to understand the Oracle Database Server Architecture, which consists of the memory structures, the background processes, and the logical and physical structures, storage structures, which this database is composed of. Oracle database, as I told you, database is a collection of data as a single unit. All this data is being stored at a particular location in a particular server, from where different users with their privileges and access rights, they get access to this particular database and they can share the information, they can retrieve the information and update the data so that the data will be saved successfully into the database. Right. So Oracle, basically it follows all the nomenclature or the rules which a general RDBMS follows. That's why Oracle database is known as a RDBMS, Relational Database Management System, where multi-users can access concurrently the given database. And the aim of any database will be of high performance, to deliver a high performance, and the main basic idea or of any database is a high availability of data at all points of time. And whenever a failure occurs, the data has to be efficiently retrieved. So keeping all these particular points in mind, even though we have so many different flavors, different types of databases, Oracle database is most widely used and it is the one which is holding the number one position in case of databases which are existing in the market. Now, the basic idea of any database server is we have a client system and we have a middle tier where so many different types of architectures are being present, and they help to access the database server where the data is stored, and this particular data can be retrieved and shown onto the user screen who is making a request. And this request, generally we call it as a query. So query is being sent to the database server. Based upon the query, the request is taken and accordingly the output of that particular query is being once again displayed onto the server. And here I was showing you example of a single computer, but in reality there will be so many different types of computers, many users who are accessing. That's why we are calling it as a multi-user environment with so many different types of architecture, which is called as a multi-tier architecture. As I told you, a database user can connect to an Oracle server in any of the two ways. Generally, if the Oracle database and the user are on the same system, so with the help of user ID and password, he can log into the system, he can make a session, he can get the data, whatever is required by making a connection pathway, and the data communication takes place and the data will be displayed. But in reality or in general, what happens is the client systems will be far apart and we have an Oracle database server located at a particular location, and the clients make a request, they go through the network through so many nodes and finally it reaches to the Oracle database server, and with the already established or defined configuration for that particular user, the database connection will be set up and the data will be transmitted from the backend server to to the client system. This generally happens in the real scenarios. Right. So as I told you, a database user makes a request, he initiates a request for the operation to be performed on the database server. The request is taken and it is being processed and sent to the server. Here, there should be someone at the server once a request comes to handle that particular request. And we generally call it as a server process. So Oracle creates a server process once a request comes from the client, and whatever memory structures or process structures or whatever information is required for that particular client, that will be created by the Oracle database server, and there will be someone who can handle that particular request. So as making like this, what happens is, in general, so for every request which is coming to the Oracle database server, there will be a particular agent or a particular type of process which can handle the information which is sent by the client. So many clients, they can simultaneously run or execute the data against one server. So this is the basic idea. What I was trying to give you is, we generally have a particular server and there will be so many hundreds of clients who makes a request to that particular server, and they can share the data from that particular server. That is the advantage of any database, as we know. Now, if I see the Oracle database server architecture, my Oracle database server architecture basically consists of two components. One is the instance and the second one is the database itself. So to handle any database, we should have an instance. An instance is one which basically consists of two parts. Once again, they are called as memory structures and the process structures. So whenever I load my database, so to load that particular database, initially the instance has to be started. So instance basically consists of all the memory structures. It also consists of some background processes, and it has some type of already running programs which are helpful for your database to run. So every database has an instance, and once the instance is started, then only we can load the given particular database onto that particular instance. So the combination of an instance and the database is your Oracle database server architecture. Now, as I was telling you from this video, from the starting of this video, whenever a user makes a request, he sends the information what he wants to retrieve from the database. Generally, this will be in the form of queries. Say, for example, if I write a query, select star from EMP. And EMP is a database that is being present inside a particular database. So the information of the EMP has to be retrieved. So user, after giving his validations, after giving his privilege, after giving his credentials like username and password, he will be validated and he will make a request to the given particular server. So once a request has been generated at the Oracle database server, we generally have a server process, and server process will look after the process which comes from a particular client, and this particular server process is for a particular client, it is called as a PGA, that is called as Program Global Area, or generally we also call it as a Process Global Area, which handles a particular request from the client. And after establishing, so once a request has come, before making a request, we generally establish a connection from the client to the server by passing the information, and at the server side there will be a network listener who listens for all the incoming connections, and once it makes a request, it gets a request, then appropriate communication path will be given so that the user can communicate with the given particular database or the objects which are present in the database. So as I told you, EMP, select star from EMP is a database object which belongs to a particular user, and to handle that particular data, this user process sends the information and that will be sent to the server, and server access that particular data. So basically, once again, I want to make you clear, my Oracle database consists of two parts, two components. They are called as instance and the database. So instance is once again a combination of two things, that is memory structures and process structures. And memory structure is known as a system global area, where all the common information is stored and which can be accessed by all the users of the database. And we have different process structures, and these process structures, they are called as background processes, which are helpful for your instance to run and to make a database to give the appropriate values. And these database storage structures, they are the physical structures which are present inside my database. They are generally in the form of files, and we have different types of files. We shall see across this lecture what are the different types of files present in my database storage structure. See here, for this particular diagram, the explanation has been mentioned here. As I told you, a basic Oracle database consists of two things, that is database instance and Oracle database, which is storage structure. And once again, this database instance is combination of your memory and process structures. And there are three major structures in Oracle database server architecture. They are memory structures, process structures, and the storage structure. So the database consists of both physical structures and logical structures. Physical structures are structures which are present inside the disk, and the logical structures are the structures which are part of your Oracle database itself. So logical structures are useful in order to efficiently manage the physical structures. So the data can be initially stored in the logical structures, and once it is committed and completely done, it can be pushed off to the physical structures, where we store the data in a persistent manner. As I told you, instance consists of memory structures and background processes, and every time we start our database, first instance will be started. A shared memory area called SGA, that is system global area, will be created or allocated, and all the background process which are related to that particular database will be started. And we have so many processes, background process, which perform their work in order to see that they are doing so many tasks. We have some process like log writers, database writers, archivers, then recovery writers, and we have SMONs, checkpoint processors. So all these are background processes which are helpful to perform different types of operations on your particular database. A process is defined as thread of control, that is steps that can be performed in order to solve a particular task. So once the Oracle instance is started, then we associate a particular database, we attach a particular, automatically a particular database, whatever has been mentioned, that will be attached to that particular instance, and that will be allocated, or which becomes part of that particular instance. And this process is called as mounting. So mounting is the process of loading the instance, and after loading the instance, we associate a particular database which has to be accessed by different users to that particular data, to that particular instance. And there are multiple users who are accessing this particular database. Now, if I see the configuration, generally, see here, this is a non-clustered system. We have local storage area, and we have the servers, client systems, which can access this particular data. Or we can have a database which is shared among so many different types of clustered systems. These are called as racks, and the data will be shared among these racks, means multiple instances will be there and they share the same database. So these are the different types of configurations that are available or that are there where we can access our database. Then database configuration, as I told you, each database generally is associated with one and only one. Each instance is associated with only one database. And if you have multiple database on the same server, then there is a separate and distinct instance for each database. What does this mean is, say for example, once I load my instance, one instance can look after one database. And if one database is shared among so many different types of so many different types at different locations or different rack servers. So in each and every rack server there should be a instance which is associated to the same database. So one database can be associated with so many instances, and multiple instances across different servers, they act upon the same database for performing different types of SQL queries or operations, or reading the data, or storing the data, or updating data, whatever it is. So a real application cluster, as I told you, it has multiple instances on separate servers and they share the same database. And in general architecture, where we have large amount of data, we generally go for this rack servers or real application servers. But for organizations, for smaller organizations, generally we can go for this particular type of architecture where there is one database instance associated with one database. The connecting to a database, as I was telling you in this class, a user makes a query. At the SQL prompt, he writes a query, and that particular query is being sent to the server process. At server process, a PG is being created by your particular Oracle database server once a request comes, and already the instance is started and database is associated, and here whatever authentication parameters the user has sent, those will be evaluated, and if they are right, the session will be established, and whatever data has been requested by the user, that is being sent, and it will be displayed on the screen of the user. So generally in the first step, what we do is the connection will be established between the user and the database server. Once the connection is established, the data has to be transferred from the destination to the user. So we have the session. For the amount of time the user is connected to the particular database server is called as session, and throughout the session is alive, the data can be transferred or it can be retrieved, or you can do any type of operation. User can do any type of operations on the database. So as I told you, communication is a path between a user process and an instance. Then session is a specific connection of a user to an instance throughout the process through which it is alive, and user can log in and access the data. So the same thing I have explained, a connection is a communication pathway between the user process and the Oracle database, and session represent the state of current user login to the database instance. And once the username and password have been established, means has been authenticated, you can send or perform any type of operation. Now multiple sessions, from different sessions with the same username and password, a user can log in and he can perform the operations concurrently from different locations, and he can access the data. That is called as multiple sessions for the same user. Now as I was telling you, this is the part of the instance which has been loaded, and the memory structures, as I told you, my Oracle instance is made up of memory structures and we have processes. And inside the memory structures, the different types of memory structures which are available are, we have a SGA, which is a shared area, and it is called as a system global area. But system global area has a shared pool where different users can access the same data. We have a database buffer cache. Whenever some type of information is written to a particular database file, first we write into the buffer cache, that is called as, the area is called as database buffer cache, and say sometimes the information may be lost due to some reasons. For that reason, we maintain some area to store the data which is ongoing and which is not still committed. That is called as a redo log. So we have redo log buffers. To do large amount of processing, we have large pools. Java specific information, if you want to perform, if the user client is using Java related activities, we can go for Java pools. For the communication between different servers of Oracle, we can go for stream pools where data is sent in the form of message communication, and we have keep buffer pool, recycle buffer pool, and buffer cache. So all this particular information is part of the system global area, and this is created once the instance is started. Means the instance is created means the system global area has been created. And we can allocate the memory required for my particular database for that particular system global area. That is SGA, how much amount of memory is required for me to associate to a particular database, that can be mentioned in a particular file called as SP file. That is called as a server parameter file, which holds all the configurations of my database. Initially, how much amount of SGA has to be defined, that can be written inside my SGA file. Now, as I told you, for different users, different server processes will be created, and for each individual user, we have an area called as a program global area. That is called as a PGA. When a user initiates a connection or wants to communicate with the server, in order to look after that particular user, activities, a separate process is created, and that process will be responsible for all the activities that particular user is creating from the start to the end, and that is taken care by a particular area that is called as a program global area. So for that particular user global area will be created, and to perform its operations, we have some stack space where the data can be loaded and it can be processed and can be set. So here two different users are accessing, so two different PGAs are being used. So these are the basic memory structures which my Oracle has, and each particular structure has its own importance. Let us see that. See, Oracle database creates and uses memory structures for various purposes. That is for memory management, the code that is being run, and the data that is shared among so many users, and some data which is specific to a particular user, that is the private data user. The two memory structures, as I told you when the instance starts, are SGA and the PGA, and SGA is responsible, is a group of shared memory structures known as SGA that contains all the information of Oracle database instance. And this SGA is shared by all the servers and background processes, means it is shared by all the server processes and the background processes. Example of data stored in the SGA include the cache data, what I have told you, the cache data blocks, the shared SQL areas, the libraries, the data dictionaries, and which are common to all the users or which are common to the particular instance. Everything will be present in the SGA. And PGA, as I told you, it contains data and information for a particular server or background process. A PGA is non-shared memory, means it is specific to a particular user on which it is working. Access to the PGA is exclusive to that particular server process, and each server process and background process has its own PGA. As I told you, a PGA server process will be created, and the background process will be looking after this particular server process. Then, see, shared pool. What is there in the shared pool? As I told you, one part of the SGA is the shared pool, and the shared pool consists of your library cache, the data dictionary, different types of objects which are part of the Oracle, like views, indexes, which are common to all the users. They are stored in the data dictionary cache, and we have control structures which controls all the information. And some data which is already used by so many users, like say for example, let's say one user says select star from EMP, and another user also says select stars from EMP, and multiple users write that, and they all share the same block of data which is being fetched from the physical database and loaded onto the SGA, that is shared SQL area. The reason behind this is, once we share, we can reduce the number of IO operations or disk operations to go to the disk and bring the data. So if already the data is loaded onto the SGA, then first your particular server process checks whether the data is present in the SGA. If it is not present in the SGA, then only it goes for the data file. If it is already present, then if it can make use of this particular data, the particular data which is present in the shared pool, users data or employees data or employee tables data, whatever views data, that can be accessed by my particular user. And data dictionary is generally called as metadata, that is the information which makes your particular Oracle to work. So it is also a collection of different types of objects like tables, views, synonyms, indexes. So different things which are helpful for my particular Oracle to work. They are called as data dictionary cache. And we have a library cache which consists of the library information like printing or some spoofing. So for all these things, we have some amount of area which makes use of a common area that is called as a library cache. And as I told you, large pool, if I have large amount of transactions to be performed, we go for a large pool, Java specific Java pool. See here, the shared pool portion of the SGA contains the library cache, the data dictionary cache, the SQL query result, the function result cache, and buffers for parallel execution of messages and control structures. And the data dictionary is a collection of database tables and views containing information about the database, that is metadata. Oracle database access the data dictionary frequently during SQL statement, that is for parsing and for its execution plan. This access is essential for the continuing operation of Oracle database. And the data dictionary is accessed so often by Oracle database that two special locations in memory are distinct to hold the data dictionary. So as I told you, the shared pool basically it has the library cache and the data dictionary cache, which can be shared by so many different types of users who are accessing that particular data. So the memory structures in common, they are being used by different types of users, and Oracle supports the common sharing of the data so that there is no need to perform IO operations again and do the tasks. One area is called data dictionary cache, as I told you, and the other area where the common data, that is cursors data, is being maintained, that is called as a library cache. So we have data dictionary cache and the library cache. Oracle database represents each SQL statements that it runs with a shared SQL area, that is PG, for every user which is specific to a particular session. And if it is private, as I told you, a program global area will be created and that can be accessed. So Oracle database recognizes when two users are executing. So here it is the one when multiple users are executing, how your Oracle database will recognize to which particular table or from where the data has to be retrieved. So it makes this differentiation with the help of the server process which is maintaining this PGA structures. So individual users, they have their own data. Database buffer cache. As I told you, all the data which is loaded from the disk inside the Oracle instance, which holds the SGA. The SGA has a part called as database buffer cache. And all my transactions, once I make some transaction, once I write some data, once I insert some data, or once I update some data, all those will be written initially into the database buffer cache. Once they are written into the database buffer cache, once you say commit, then only the data will be transferred from the database buffer cache to my data files. That is the persistent storage media, the permanent storage media, that is hard disk. Until that time, all your data is being present inside the Oracle's database buffer cache. So as I told you, database buffer cache is part of SGA. It holds copies of data blocks that are read from the data files, and if user is writing anything, that also will be kept in the database buffer cache, and it is shared by all concurrent users. Since it is shared by all the concurrent users, the architecture has been built in such a way that it is part of the SGA. So we have database buffer cache, which is part of system global area. See, the database buffer cache is part of SGA, as I told you, and whenever a user is writing a query select statement in order to retrieve from the hard disk, that is database, the data will be loaded onto the database buffer cache, which is part of SGA. And initially, if the data is not loaded, it will be loaded. If the data is loaded, it will be kept in the database buffer cache and different users can write. When user makes a query, it will look after whether that particular query's required data is present in the database buffer cache. And if the data is present, that is called as a cache hit. If cache hit occurs, there is no need to once again go to the data files and retrieve the data. because already in the database buffer cache, which is part of the Oracle database, SGA data is present that can be retrieved and shown onto the screen. And if the data is not present inside the database cache, then your Oracle makes a recommendation to go to the data file, retrieve the data from the data file and keep it in the buffer cache. That is called as a cache miss. So if more cache hit occurs, means less number of IO operations are required. Anyhow, for the first time if we are loading the database or data file, data related data, it always has to load, then in that case it will be cache miss. Sometimes in the organization, you will be repeatedly doing the same transactions on the database and multiple users will be using the same database or same information. In such case, this cache hit or this concept of database buffer cache will help out to reduce the time that is required in order to perform different types of operation. So accessing data through cache hit is faster, obviously faster than the data access through a cache miss. See here, the buffer and the cache are managed by complex algorithm. The algorithm which is basically followed in Oracle is the least recently used. The least recently used blocks are always maintained inside the database buffer cache, and which are not used, they are generally sent to the data files for storage. And the one which you are using mostly, that is touch count, that will be always present in the database buffer cache. And this keep buffer pool and recycle buffer pool, they are used to adjust if you are using some transactions regularly, a large amount of transactions are being used. If you want to store something in the memory for a longer time, then you can go for the keep buffer pool. Like this, we have additional buffers which can maintain and which has the data that has to be stored. So the important one here is the database buffer cache, which maintains all the shared data inside the Oracle database. And the other one is the redo log buffer. As I told you, all the information which is present in the database buffer or which is given by the user, the transactions which are performed by the user, they will not be committed statement by statement. If you want to commit them statement by statement, what happens is the IO processing, sending this data from the buffer cache to the data file takes time, and your database takes long amount of time in order to perform the operation. So generally what we do is in batch wise a group of transactions are being saved. So in such process, for some reason, if some of the transactions are already done and they are not committed to the database, and for some reason there occurs a failure due to power failure or the software failure or the hardware failure or the user failure or session failure or any type of statement failure, in such scenarios the data which is in the database buffer cache, it has to be retained. So simultaneously what your database does is, Oracle database does is, it maintains another buffer called as a redo log buffer. Inside the redo log buffer, the online going transactions which are not still committed, they will be kept inside the redo log buffers. They are being placed inside the buffer called as the redo log buffer. So the redo log buffer, it's a buffer area which generally maintains the online transactions which are yet to be committed, means which are not sent to the data files. So if I see here, see a redo log buffer is a circular buffer which is part of the SGA. It holds the information about changes made to the database. It contains the redo entries that have the information HTML and DDM. And this redo log buffer, they write the data into the redo log files which are part of your disk. And whenever the system fails, this particular data which has been done, that will be recollected from the redo log files. So redo log files are maintained in order to see that the ongoing transactions are not being lost and they can be recovered. So this concept is called as roll forward. So whenever transaction is being not committed, the data that is stored inside the redo log buffers or which is written into the redo log files, that will be collected back, and at the time of restart of the instance once again, once you restart your database, all the data which is present in the redo log buffers is being recollected, and that will be applied by a process called as SMON, that is system monitor. The work of the SMON background process is to look after the ongoing processes which have failed and to recover and to bring to a consistent state, to bring your database to a consistent state so that none of the transactions are being lost. See, I was telling you about the redo log buffer. The redo log buffer is a circular buffer in the HGA that holds information about the changes made to the database, which are done by the DDL and DML statements. As the server process makes changes to the buffer cache, redo entries are generated and returned to the redo log buffer, as I explained you. So the redo log entries generally take up the continuous or sequential space in the buffer, and once it is full, they will be automatically returned to the redo log files. And we can have a number of redo log files or group of files on the hard disk to store this particular information. Generally, so redo log buffer generally they are helpful in order to recover the data of the ongoing transactions. As I told you, large pools are generally used for storing or performing large amount of data which require graphical interfaces or interacting with the server process, or to perform the backups and restore operations. Right, as I explained to you, large pool is very important when you have large amount of time, but if it is a smaller organization, the large pool area may not be used much. But we allocate the large amount of memory so that heavy transactions can be performed in the large pool. And as I told you, Java pool and Steam pool, these pools are useful when you write some Java related code or Java specific session specific code in order to retrieve the data, and we use the JVMs. And stream pools are useful in order to exchange the information from one server to another, or to send the data from one Oracle server to another Oracle server or large servers in the form of message communication. This is Java pool memory is used to store all specific session data, and the stream pool is used exclusively by Oracle streams, as I told you. Oracle uses stream pool in order to send the data, it buffer the messages and retrieve the data and applies the process. And this is, we understood what is SGA. SGA is basically a common area where we share all the information related to different types of processes or different types of users or different types of database objects, and we have the data dictionary cache and the library cache. And when it comes to a specific user who is making a request, a particular PGA will be created by the server process. And in the server process is basically consists of these particular things. They are called as cursor state, the user session for that particular user. If you are writing any sort operations, sort area, or indexes and bitmaps or hashing to combine two tables or do something, then we have a hash area. So SGA we have for common data, and for single user we have a PGA. So the PGA is a private memory region, as I told you, for a particular server process. Every PGA contains a stack space to load up the data and to perform that particular data. And it has a UG also, user area, user global area where user can perform his tasks. And cursor area where all your data from the table is being loaded onto the cursor area, you perform the task, and database, after performing the task, the database buffer cache or the database writer will write into the database. So as I told you, the operations performed on the PGA are operations like order by or a group by, and a hash area for joining some tables, inner joins or outer joins or equi joins. And for data warehousings, we can have bitmaps, index, so that we can retrieve data from different data warehouses. And so in generally what happens is SGA and PGA, they communicate and they try to store or send the information as requested by the user. So instance, as I told you, it is a common part which holds both SGA and PGA along with the background processes. See, process architecture, any process, a particular PG or process architecture, the whole architecture of the Oracle database, it generally has three parts, as I told you. the user process, the database process, and your applications. The applications which are running at the background, they are called as daemon process. Like establishing the connection, we have network listeners from which user the database connection is coming and to whom this database connection has to be given. So there will be a listener. So the network listener makes a connection for a particular user to this particular database, and that particular listener will be responsible for transferring or sharing or updating or sending data from one user to the database server. And user process, as we studied, as we understood in this session, it is the application tool that connects to the Oracle database. And database server consists of Oracle instance, and it also consists of the memory structures which are helpful or which provides the connection between the user and the Oracle database server. And as I told you, the Oracle server, the Oracle processes, already they have so many background processes. And all these processes, they will be started when your Oracle instance is started. Otherwise, manually also you can initiate some of the background processes which are required and which are helpful for a particular Oracle database to run. See, the process in an Oracle database consists of three major groups: user process, the Oracle database that run the Oracle database, and the Oracle daemons. That is the processes which are running in the background. And I told you how the connection will be established and how the data can be read. See here, this is the diagram which is showing you a user process. He makes a request to the given Oracle database. The Oracle database consists of my instance. An instance has SGA and background processes. And once a connection has been established, once a request has been made, your Oracle database, it creates one server process and it allocates a PG, that is called as Program Global Area, which looks after the specific activities of this particular user process. And once a connection has been established, so to establish the connection, the Oracle database, that is server process, it creates a listener, the network listener. Once the network listener is created, we have the port address, the port to which it has to be connected, the username and password, and all the details required for the connection to which particular server it is connecting. Everything is being listed in the listener, that is called as TCP IP listener. And the user makes a request, the listener gives the connection on request to the server, on request to the database. So once everything is fine, the communication path will be established, the session will be established, and the data can be shared, accessed, updated, or retrieved from the database. And the other part is the background process. If I see there are different background processes in the SGA, they are the database writer, checkpoint background process, the log writer, the system monitor, that is SMON, PMON, and recovery process. Apart from that, we have an archiver process and some other processes. The work of the database writer is to write into the database. The work of the checkpoint writer is whenever some transaction is being updated or being done, and if still the data is not being committed, that particular data is written into the checkpoint header of the data files, as well as the checkpoint process maintains some number called as SCN number to find out to what extent the database has been written with the transactions and which is not yet committed. And the log writer, as I told you, the log writer is responsible to store the online redo log information. Means that information which is not yet committed, which has been added to the database buffer cache, which is under the process of writing into the database, such type of information will be written into the redo log files with the help of a background process called as a log writer. And system monitor is a process which is useful for recovery. When something fails, when your database fails or hardware fails or disk fails, and once again you reinitiate or restart your database, the instance will be loaded. At the time of instance loading, the system monitor, the SMON process, is responsible to retrieve all the data which is present in the redo log files or which is present in the archive files or which is not yet committed, and to bring to a state which is called as database consistent state or read consistent state, so that my database will be in a normal state at the time of loading, at the time of opening. And for user specific data, say connection is lost or some data is not being updated, so PMON process is responsible for any type of operation that is being performed. And we have a recovery process for large amount of data. If the data fails, we have a recovery process. See here, these are different. As I told you, server process is responsible to start the server and connect to the instance. The user process makes a, as I explained, the user represents the application, or it sends a connection request, and your Oracle database server from the remote server to this particular remote client, it establishes a connection via the listener, and the listener is helpful in order to communicate between the client and the server. Either we can have a shared servers or we can have a dedicated servers. So in general, what happens is the SQL statement will be issued from the application that will be sent to the shared database, that is database buffer cache. It looks whether that particular SQL statement is present in the buffer cache. If it is not present, it is going to retrieve from the data files and load it onto the buffer cache and perform the task. And finally, it returns the results to the application which has made a request. See, background process, different background processes I told you, like database writers, log writers, then we have archive writers, and we have SMON and PMON. Yeah, as I told you, the database writer will write the data onto the data files. So it writes the modified data, which is called as a dirty data, that is dirty buffers, inside to the data files. Then see, if you see here, see, this is the modified data, and this modified data, with the help of the database writer process, it is written to the data files. And we can have any number of database writers assigned at the time of creation of the database. Generally, there will be database writer to write. If you want fast execution or storing of the data, we can have multiple database writers assigned, like from DB1 to DB9 or any number of database writers. So at the time of writing, the database writer, whatever data it has written to the data file, that will be written to the data file, and that information is also stored inside the checkpoint file, so that whatever data has been written, that can be known. And it maintains the information which is written onto the data files with the help of some sequence number that is called as serial change number. With the help of this particular number, it identifies which row has been written onto the data files. So there are different types of data. We have so many database writers which writes onto the data files. And the log writer, as I told you, the log writer, it writes the data from the read log buffer onto the read log file. Generally, it writes when a transaction is committed, or when the read log buffer is 1/3 full, or whenever a database writer modifies buffer to the disk, or automatically it writes for every 3 seconds. So transactions will be so fast, so continuously your read log buffer, whatever data is present in the read log buffer, with the help of log writer, it is being written to the read log files. The log writer is responsible for read log buffer management by writing the read log buffer entries into the read log file. Log writer writes all the redo entries that have been copied into the buffer since the last time it wrote. So I told you what are the different scenarios your log writer is going to write onto the read log files. Checkpoint. Whenever information is added and whenever information is kept moving, means is being added, that information with the help of checkpoint process, it is written into the file which is called as a control file. And the control file has a header, and inside that particular header, until what particular point, data point, the data has been saved and how many records have been saved, everything is written. Each data file has its header, and inside the data file header, the information regarding to what extent the database has taken the transactions, all that information with the help of the checkpoint process, it writes onto the data file. This checkpoint is required whenever a transaction fails or whenever transaction is aborted, from which particular point again the transaction has to be recovered. from which particular commit point the transaction has to be recovered. To get that particular information of a transaction, we generally have the checkpoint process. So the checkpoint process writes both into the control file as well as the data files. So a checkpoint is also a data structure which has a system change number, and for every transaction that is not being committed and to which particular point it has to be rolled back, that information is written inside the checkpoint process or checkpoint files. And when a checkpoint occurs, Oracle database must update the headers of all data files. This is done by the checkpoint process, and the checkpoint process does not write blocks to disk. As I told you, only database writer will write the blocks onto the disk. The checkpoint process is there to note till which point the data has to be entered whenever a failure occurs, or at which particular point of time the database has to be committed. So such type of information is present in the checkpoint, and the information that is written onto the database is always done by the database writer. As I told you, SMON is a system monitor that is useful for recovery. It performs recovery at instance startup, and it also clean up the unused temporary segments at the time of transactions. If any segments are created and which are not used, such type of all unnecessary segments are being cleaned in order to maintain the disk fragmentation. System monitor performs recovery at the time of instance startup, and if necessary, SMON is also responsible for cleaning up the temporary segments that are no longer in use. And SMON recovers the data of the table or the table space when it is both online and offline. Offline recovery is very easy, but online recovery you have to add some extra parameters, and you have to look after different types of configurations when you are taking the backup which is at online. And the online backup is called as a hot backup. And the database, when the database is closed and you are going to take the backup, that is called as a cold backup. Cold backup is easier compared to that of hot backups, because simultaneously you are taking the backups and the database users are going on writing the information onto the database. So SMON checks regularly to see whether the process is needed and calls SMON whenever there is some type of recovery. And process monitor, as I told you, performs process recovery for a specific user. Right. See here we have a user, and whenever a user fails, some amount of data is already written to the database buffer cache pertaining to this user, and this has to be recovered. So PMON is responsible for this particular user A. Say for example user is A, and the server process which consists of all the background process and all the information related to check for this particular user. With the help of this, your PMON process will recollect all the information required, and it will bring to a consistent state for that particular user. So monitor sessions for idle session timeout. Sometimes the session may be timed out and it may be closed. Then the PMON tells the server the session has been closed, and again a new session has to be initiated by that particular user. So the process monitor is responsible for performing the process recovery, and PMON is responsible for cleaning up the database buffer for a particular user, and it resets the status of active transaction table, the release logs, and performs some other activities which are particular to that particular user. PMON periodically checks the status of dispatcher and the server process, and if anything has been idled out or session is out, it asks for the reinitiation. PMON also registers information about the instance and dispatcher. Like SMON, PMON checks regularly to see whether it is needed. It can be called if another process detects the need. So PMON is, again to brief, PMON is specific to a particular user, and SMON is a shared or for all the users.